Hi, I'm Kinjal Das. Today I'm going to describe about a project that I have made during the internship tenure in emerging information technology. So this project is about the smart factory IoT monitoring system. This is about the real-time production and warehouse telemetry solution. So basically, when we uh, generally use some production house like factories, it is very difficult to monitor the certain vital parameters of the factories, that is the machine temperature, machine humidity, or any other parameters. So this project will help to uh, solve those parameter problem, solve those tracking problem actually. We can track those problem through our home. So let's start with our project. So this is the basic executive summary. Summary is that to provide a real-time operation visibility into the production and warehouse environment. Okay, so whatever the problem that will be facing in the main factory, there are two parts, that is the production line where the devices or certain products are being manufactured, and another one is the warehouse. Warehouse is the place where the items are kept, that is the go down. So both of these two regions we need to maintain a certain ambient environment. So for this we require certain processes. So this project deals with those processes. So what is the key functionality? The key functionality is that the sensor data collection, automated ventilation, remote control equipment and shutdown, and as well as alarm management. So basically, we are collecting data from different sensors like temperature, humidity, then the ambient temperature of the machines, either the machine is on or off, whether the room is dark of the go down or whether the door is open, like this. We can collect this data and through Arduino Uno, mainly here the microcontroller use this Arduino Uno. So using that Arduino Uno, we can transmit those data to the cloud where ThingsBoard cloud platform is used. Okay, ThingsBoard. ThingsBoard cloud platform is used for delivering the data and visualization of the dashboard. So these are required, and here we are using a Ethernet shield whose number is W5100. So this Ethernet shield is used to connect the Arduino board to the internet. So before starting with this project, the key prerequisite that I have learned, which is how to use the Pixim Lab. Pixim Lab is nothing but a software or a simulator which I have used while making this project. Actually, I have not used any practical sensors or practical microcontroller. I have used this particular software which is name is Pixim Lab. Here all the components which I required is present, as well as Arduino IDE or any other microcontroller board like PIC or AVR or ESP32, STM32, etc. So then I have learned how to download the Pixim Lab, how to configure the Arduino IDE. That is basically Arduino IDE. There certain libraries are required before configuring the main code. We require to install certain libraries like DHT22 library by Adafruit or certain MQTT servers library like that. Then I have learned about the specific architecture and pin diagram or the Arduino Uno. That is which pin is analog pin, which pin is digital pin, which are ground pin, which are specifically denoted for the transmission, that is TX and RX pin, etc. Then I have written the first code which is about the LED blinking. This is the first code that I have written and demonstrated using this Pixim Lab and Arduino IDE. Then I have learned how to use a potentiometer, that is the interfacing a potentiometer with the analog pins. Here analog pins are also present, which is A0, A1, like that. I have used this potentiometer in the further project, in our project, as the vibration sensors, like that. Okay, actually vibration sensor is not present, so that's why I have used a potentiometer. As well as for the LDR sensor, those analog pins are required. So these are all I have learned about. Then I learned about the DST22 sensor. So actually, what is the DST22 sensor? Uh, Transmit the data in digital form, that is 0 and 1. How to deal with that sensors, pin diagram, and etc. We have used then serial monitor. Here, serial monitor is not present in the PixSim lab, so there is another process that is known as the virtual terminal. So this virtual terminal is used for the PixSim laboratory. Then I have learned how to transmit the data from Arduino Uno to the cloud. That is about how to configure the Things board platform and how to connect it with that Arduino IDE through the Ethernet shield board. So these are all the prerequisites that I have learned before starting the main project. Before implementing the main project, I have used this knowledge further. Then the system overview. So basically the system is that core platform I have used is PixSim Lab and Arduino Uno simulation. Cloud Black backend, which is used as a ThingsBoard IoT platform, is used for the cloud backend. In the cloud, I have used dashboards, alarm, etc. Scope. Scope is the dual node deployment is used. Okay. First one is for node 1. Node 1 is mainly for the production line and the node 2 is mainly for the warehouse. Node 1 is production line because we have separate Arduino and separate architectural system to monitor the different parts of the production house of the factory. First one is for the production line where the product is being manufactured, and second one is the storage. So that's why we need the two different node, two different architecture, two different processes and system to monitor the different parameters. Then what are the key uses? So these are the key uses for our project. The first use, that is the main practical uses, real-time monitoring. That is the air or machine temperature. Air temperature is that the room is heated or not. That is also an essential parameter. What is the ambient temperature of the room? Either it is maintaining 27 to 31, 32 degrees Celsius or more than 35 degrees Celsius. Then vibration sensors to track those in the real time. Then automated warehouse ventilation, then threshold waste, then the remote equipment control RPC, that is how to on and off a relay through the remote control. Then the security or motion door status tracking, etc. Then fault handling, sensor error coaching to prevent the false alarm. Fault handling means whenever the sensors are not connected or sometimes the network is being disrupted by certain means, then within 30 seconds of the network, the board must connect to the cloud. So that also we have checked here. Then these are the functional requirement for node 1, that is the production line. So function requirements are, first one is monitoring the temperature and humidity. These are all about DST22. DST22 is the only sensor that will give the digital output. Okay, digital output means either 0 volt or 1 volt. Like that, 0 and 1 signals are being measured. Then it is LM35, which is the machine temperature. DST22 is mainly used for the room temperature, and for a particular machine, an analog sensor is also used that is known as LM35. This is used for room temperature. And then vibration is used as a ADC. Okay, so ADC is nothing but an analog to digital converter. So about 4 samples average is used for this vibration. It is also potentiometer. Okay, potentiometer is used for the vibration. I will be showing all this demo after completing the PPT slides. So then the control is machine on off sensing D3, that is relay, or D4, a status LED, that is D5 to D7. These are all controls. Then higher priority MQTT telemetry reporting every 5 seconds. Actually, Thingsboard uses MQTT. MQTT protocol is nothing but a message queuing text telemetry. These telemetry is much more faster and superior than HTTP. Okay, that's why I have used a Thingsboard platform for the real-time data tracking or data monitoring. After every 5 seconds, the data will be updated in the cloud platform. Then what is the functional requirement? Functional requirement for the node 2, that is warehouse. Warehouse is nothing but a go down. So what we need to sense in that go down? Either the temperature or humidity. What is the temperature, humidity? Then ambient light means go down is dark or any light is on, like that. Then PIR motion. PIR motion means any person is present inside the godown or not, read door is open or not. For this reason, we have used certain mechanisms. Like for door, I have used a switch button. For PIR motion, we have used a potentiometer, like that. Then automation ventilation relay. It activates, that is the relay will activate after 85% humidity exceeded. Okay. If the humidity is greater than equal to 85%, the relay will automatically get on. Then logic. What is the logic? That is the PIR hold timer 10 seconds for stable motor motion detect. PIR is nothing but passive infrared sensor. The passive infrared sensor will detect whether any person is present or not for particularly 10 seconds for stable motion. That will give a warning. That will give a LED indication that someone is present inside the warehouse. Then what these are the non-functional requirement. Before this, a functional requirement means the actually practically what we required to do. Those are called functional requirement. And apart from that, these are the non-functional requirement. So here the performance, telemetry reporting within 5 seconds. This is the prime factor that we require. The more frequently updated version of the data we should require. Actually, whenever a data change, we need to monitor the data within 5 seconds. As fast as we monitor, the more accurate value we will get. For this reason, MQTT reconnection within 30 seconds. So actually, whenever the line or the Ethernet cable got disconnected, and after the connection regains, the MQTT must connect within 30 seconds. Then modularity. Modularity means clean separation of concerns. That is the sensor manager, network manager, etc. So I have, while writing the code, I have used separate header files. There is a C header files and C++ files for the different program like sensor manager, telemetry, actuators. All of these files will do the separately each functions. Then the security. Security means the unique access token per node. No hard-coded credential must be there. Actually, every unique access token will create a privacy and encryption for the particular data or particular device. Then high-level system architecture. Perception tier is nothing but a node 1 and node 2 pixin lab. Transport tier means MQTT over TCP/IP or things both broker. Why we have used that I have already discussed. Then application triad is things both cloud, dashboard, ruler, and RPC. Then data flow logic. So how this raw signal to processing into sensor manager, JSON serialization to MQTT publish. So this raw signal is first converted into JSON format. Then this JSON format is published into the MQTT server. And like that, the dashboard and widget auto refresh via cloud. RPC command means remote control. RPC is just like remote control command routed from the dashboard back to the device RPC handler. Then hardware design. First hardware design is input of DHT22 D2 button, then button D3, then vibration. Vibration is nothing but an analog sense. Okay, analog signal. Vibration is nothing but analog signal. So that's why vibration is used for A8 pin and LM35, etc. A1. LM35 is connected to A1 pin and light. Outputs relay D4, LEDs D5 to D7, visualize SPI interface, etc. So here the software module I have used the configuration config.h, IP MAC and threshold, all everything is declared in the config.h. In telemetry manager, build JSON via print. Then network manager handles the auto reconnection logic. So that I was saying before, whenever the network got disconnected, auto reconnection is required. Then main sketch is for the orchestrate the state machine. Dashboard and UI design for Node 1. Layout detailed monitoring for production line. Analog gauges is invented. Actually, analog gauges are included inside the Node 1 UI for the temperature of 0 to 50 degrees Celsius. Warning must be there for the greater than 30 degrees Celsius and critical warning must be there for greater than 35 degrees Celsius. All these alarms are included inside the dashboard. And then the status indicators, LED widget for machine status, etc. And trend analysis, time series chart for vibration and LM35 machine temperature to track trends over last hours. This time series chart is also included there. For this dashboard for the UI designed for the Node 2, focus is mainly environmental monitoring and facility security. Key widget is there: environmental, humidity, gauge life, level, value card, etc. Value card is required for the LDR sensor. Security is that LED status indicator for motion and door status. Ventilation mainly the relay state monitoring plus manual override switch. Analytics is the for 6 hours. The humidity trend chart must be on. That's why so that we can monitor the last 6 hours or more than what the temperature, the rate of change of temperature and humidity occurred. Then backend alarms and rule engine. So rule engine is required for setting the setup of the rule specific rules for the alarms. For threshold like temperature must be greater than 35 degrees Celsius, then there must be critical alarm, and humidity greater than 85 degrees Celsius, there must be critical alarm. MQTT loss, that is the 30S. Fault handling detects the DHT22 failure, avoid false alarms. Rule flow temperature, input switch, input equals to switch, means from input it will be switch. Then for filter, it is the temperature greater than 35 degrees Celsius, and from then alarm creates a or alarm creates or clear. And thank you for listening to this slide. Now I am going to describe about the project implementation, that is the demo of the project. So here you can see in the left hand side, this one is for node 1 and this one is for node 2. Here you can see the DHT22 sensor, ILM35 for the temperature sensor, machine control, that is whether the machine is on or off, vibration sensor. This one is the Ethernet shield, that is W5500. This one is the Ethernet shield. VTerm. VTerm means the virtual terminal. It is the virtual terminal that I have used. And these are the three LEDs. Three LEDs is mainly used. First one is for the connection, successful connection of the Ethernet shield to the internet. It will give the green light. Whenever it is not connected for some reason, firstly the red LED will start to on, and if any sensor disconnected, this yellow LED must turn on. For example, if I connect this to not connected, then yellow LED must turn on. It is somehow right there. Yellow LED is blinking. So yellow LED is blinking means the sensor got disconnected and sensor there is something problem in the sensor. Okay, let's connect it back. Now come to the dashboard. I have created three devices, dashboard actually: production line monitor, warehouse monitor, and factory monitor. Smart factory monitor means the overall production line and warehouse data is being shown in the smart factory. First, production line. Here you can see the two gauges, analog gauges. First one is for temperature, second one is for humidity. So as we change the temperature, here it is 66%. Here it is 66%. Now I am changing it to 6% humidity, and the temperature is changing to 71 degrees Celsius. Okay, you can see that within 5 seconds the temperature and humidity is changed. See, the temperature becomes 72 degrees Celsius and the humidity becomes 70 degrees Celsius. And for that, relay state is on. You can see that relay state is on because the humidity is less. Here you can see the time series table. The last updated is just now. Just now it is last updated. Vibration sensor and sensor error. Temperature is 72 degrees Celsius and humidity is 7%. Now LM35 is the ambient temperature. Now changing also the LM35 value. 28 degrees Celsius approximately. You can see LM35 value. See, it is changed to 28 degrees Celsius after 5 seconds. And then machine status. Machine status is machine control. You have to press it for 10 seconds around to get the machine status is on or off. Okay, see, machine status is off actually. See here, machine status is 0. Then here LED also become off. See, see, LED is off, and again the machine will on. See, the machine will on like that. If the machine is off, it will show off. If the machine is on, it will show on. So this is what about the machine status. Then sensor error. You can a sensor error is already shown. If the sensor is not connected, then in the practical there also LED will be blinking yellow LED. Here also the sensor error will be on. Now vibration. It is a vibration sensor. A potentiometer is used. Now I raise the value of the vibration sensor. You can see the vibration is 900. Vibration becomes 900. So this is the real-time data. Real-time data is being monitored here using this time series. And here you can see the alarms. Alarms are used like that. Whenever the temperature is high, this critical alarm is blinking. See, this one is for high temperature critical alarm. In the devices, I have also created this production line. Actually, here in the telemetry, latest telemetry, that all the values are coming. All the values are coming here. And here I have set the rules for vibration alarm. Just like that, if we start to talk about this one is warehouse part. Similarly, warehouse part, if we come to the dashboard, warehouse monitoring, here also we have LDR value, widget card, value card, time series chart for the last 30 minutes, humidity gauge, temperature gauge, time series table, and alarms. So let's change the temperature. Humidity is changed, temperature is also changed. See, the temperature will change within 5 minutes, 5 seconds, sorry. See, temperature become minus 21 degrees Celsius and humidity becomes 78 degrees Celsius. So this is how the temperature and humidity will got change in the real time within 5 seconds. Then is dark. Is dark is for the whether the room is dark or not. Is dark will be on if the LDR value becomes less than 300. Sorry, greater than 300. So change the value. See, is dark is on. Here you can see the LDR value become 4 and is dark is on. That means the room is dark. The room is absolutely dark. There is no light. That's why is dark is on. Here the LED is on. Then door status means door is open or not. Here it is shown on. Here I have used a door switch. If I close the door, if I close the switch, it will show the door switch off. See, here the door is off. Door switch is off. Door status off means the door is closed. And then motion detection, there must be steady motion for at least 10 seconds. So I am pressing this PIS sensor button. Actually we have no PIS sensor in PiximLab, so I have used a button, a switch, to replicate the characteristics of a PIS sensor. So whenever I am pressing this switch for 10 seconds, it will replicate the value in real time. I'm pressing it like 10 seconds. Okay, now you can see the motion detected is on. See, the motion detected is on. That means there is someone in the warehouse. After some time, if it not on, then it will automatically go off. There is a LED will turn off. See, the LED got off. And here also this one is the Ethernet shield, and this one is the VTerm. VTerm means the virtual terminal. This one is for ventilation relay, LDR value, door switch, and PIR sensor. Here also I have included the time series table, and here also the alarms are here, critical alarm and warning, real time last 30 days. This alarm will be real time or 30. You can acknowledge these alarms. So this is all about the smart factory monitoring system project, and thank you for listening to my video.